Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing the product of some term. So before discussing the POS representation, a Boolean expression consisting of entirely either minterm or maxterm is known as a canonical expression. So a canonical expression may consist of minterms and maxterms, and the basic two forms of canonical expressions consist of SOP, that is sum of product, or POS, that is product of sums. In this lecture, we are discussing the second one, that is product of sum representation canonical expressions. So my dear students, a Boolean expression consisting of purely max terms, that is sum terms, is said to be a canonical product of some form. So simply a SOP representation or SOP expression consisting of max terms, that is sum terms, which is producted or ANDed. For example, let us say if we have Boolean function f defined on two variables a and b, so a and b are the input of f. Let us say the output of f is true, that is f is equal to 1, when and only one of the input is true or 1. So if we draw the truth table of f, a and b combinations are 0, 0, 0, 1, 1, 0 and 1, 1. So as we discussed, the output will be 1 if and only if any of its input value is 1. That is 0, 0 combination results in the output 0. 0, 1 combination results in 1 since we have one input value. 1, 0 combination also results in the output value 1 since we have one input value. 1, 1 combination will result in no output or 0 since both of the inputs are present. Now we can create a column for the max term using the variables a and b. If input is 1, we take the complement of the variable, and if input is 0, we take the variable as is. So therefore 0, 0 can be represented as a plus b. 0, 1 can be represented as a plus b complement. 1, 0 can be represented as a complement plus b. 1, 1 can be represented as a complement plus b complement. To get the desired canonical POS expression, we will multiply the max terms for which the output is 0. Therefore, as from the truth table, we know that the output value is 0 for A-B combinations of 0, 0 and 1, 1. Therefore, the POS representation will be f is equal to a plus b dot a complement plus b complement. So my dear students, now we are converting a POS representation to a shorthand notation. From the previous example, we have f is equal to a plus b dot a complement plus b complement. Now let us say we want to express the POS using shorthand notation. So we have f is equal to a plus b dot a complement plus b complement. First we need to denote the max terms in shorthand notation. That is, the term a plus b is equivalent to the binary number 0, 0, which is equivalent to m0, capital M0. And a complement plus b complement is equivalent to 1, 1, which is equivalent to m3. Now we express the function using the shorthand notation, that is f is equal to a plus b dot a complement plus b complement can be represented as f is equal to m0 dot m3. This can also be written as f is equal to pi of 0, 3. Let's say we have a Boolean function f defined on two variables a and b. So a and b are the input of f, and let us say the max terms are expressed as shorthand notations given below. F is equal to pi of 1, 2, 3. Our task is to get the POS representation or POS equivalence. F has two input variables a and b, and output of f is equal to 0 for m1, m2 and m3, that is second, third and fourth combination. We have f is equal to pi of 1, 2, 3. That is, f is equal to m1 dot m2 dot m3, or the binary equivalence will be 01 dot 10 dot 11. To convert from shorthand notation to POS, we follow the given rule. That is, if the variable is 0, then it is taken as is, and if the variable is 1, then we take its complement. So we have f is equal to pi of 1, 2, 3, which is equal to m1 dot m2 dot m3, which is equal to 01 dot 10 dot 11, which is equivalent to a plus b complement dot a complement plus b dot a complement plus b complement. So this is the required POS of f is equal to pi of 1, 2, 3. So my dear students, in this lecture we had discussed the POS representation. So POS, or product of sum, is the AND operation of all the Maxterm variables or values. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. The assignment question is: define canonical expression. Secondly, define product of sum or POS. And thirdly, write notes on POS in detail. So my dear student, in the upcoming lecture we will discuss the Boolean expression simplifications, the various simplification methods for Boolean expression. So see you soon. Until then, goodbye, thank you, and all the best.